Hello, good morning, everyone. It's a
Morning.
pleasure have you here in Ircad Barretos to have this our next Ircad and coffee. With this time, is have another great team to put everybody together in the same philosophy, the Ircad team. And for me, it's an honor to have here important people from Ircad, and this is the idea for this Ircad meeting. The next two weeks ago we did once, and today another, and we have more new ideas for the next meetings. And for now, I'd like to ask to Professor Melanie that he is here with us to introduce this meeting, this Ircad and coffee with friends. Armando, it's a pleasure have this time with you and the team. So it's you to you are the chairman of the group, and I'd like to give to you the opportunity to speak and explain this idea and introduce everybody. Thank you.
Thank you, Luis. Good morning, everybody. Good evening, Jack and David. Uh, Mariano, good morning, my friend. It's a great pleasure to receive you all here. The idea of this breakfast in Latin America is exactly to exchange some philosophies and idea related to innovation. So we choose this first module to start with people that used to work abroad. Jack representing Ircad Taiwan. Uh, David is representing Ircad Africa, and our good friend Mariano, he was in Argentina, and nowadays he's half time in Argentina, half time in France, developing his work. And so imagine as you as a surgeon or as an engineer that wants with work with medical device or something like that, and you are located in a place like us, Latin America, and you want to understand how to make this happen, and you want to understand about the research of these people, and this is the main idea of this meeting today. It's a discussion. This is why I encourage you that you are connected with us to send messages and questions for this interaction, because it is very important to know how Mariano start in Buenos Aires and move to France. Everybody wants to understand how it works. Beside his very powerful surgeon, and he has great idea. We cannot speak nothing about his ability because he's a Superman when he's playing with his tools. But we want to know, and more than that, he's creating a legacy over there. So it's my great pleasure, Mariano, to have you introduce you for the first presentation, and I know that you are always very focused to develop young generation. Uh, your uh, you are the guy that try to bring with you a great team and try to motivate them and make them create new innovations. Please, it's my pleasure to hear you.
Well, thank you very much for your kind introduction. And Luis and Armando, thank you for your kind invitation. I think it's a very interesting idea to talk about this. I'm sorry, but I reduced this now. Okay. Of course, it's one topic. One interesting topic is it said, well, it's possible one surgeons, classic surgeons in Latin America, has work in the research, develop, and clinical practice in the best place in the world, in the Ircad France and the new center of the ISU, etc. Really, it's possible, but it's necessary work in the teamwork. And really, is I work with my team work in Buenos Aires, and in the Ircad family, I totally agree with Luis and you. Ircad family really is a powerful team, an international team of the very interesting people. This is my disclosure. Is in 2016, Professor Jacques Maritkov finished the one institute. This institute, ISU, is University Hospital Institute, is connected by Ircad Strasbourg by the bridge, and connected with the University Hospital for another bridge. It's 3 floors. The 3rd floor is for research. The 1st floor is for a surgical room for patient, and the 2nd floor is labs, and is 3D printers, is a computer and robotic work, and is 50% engineers, 50% doctors. It's a new idea of a team of teams work together all time. It's fascinating. It's incredible things. This institute has 9 operating rooms in the 3rd floor. 3 of them is a new concept of hybrid surgical rooms. It's the classic with laparoscopy, endoscopy, robotic, etc., plus images, CT, MRI, and robotic. And this is the connection of 3 of them is with the classic laparoscopic is fantastic. This is a 3 hybrid OR, is number 1, number 2, and number 3. And in the this is one hepatic and percutaneous surgery with Patrick Pesot, and this is one percutaneous and laparoscopic ablation in different days. It's one of our young Latin American fellows who work with us in Strasbourg, Dr. Alan Garcia from Mexico. And at this moment, Alain Garcia has planning one with this navigation system, planning one ablation in this patient. In the 3rd floor, we have the same machines, CT, angio, MRI, and laparoscopic, endoscopic, for research and develop a new devices and new surgical techniques and training. Of course, we have extraordinary progress in our surgical images, not only in robotic, not only in laparoscopic, in the CT and MRI. For example, this CT is possible to view very well the portal vein and the liver. I use the liver example and more the ablation for the example for my talk today. For that reason, we work with immersive technologies all time, more and more in our practice. Armando has a huge experience in the augmented reality in his colorectal surgeries. We have augmented reality is more similar to digital photo, etc. More virtual reality is, for example, the virtual reality games. And in the middle, in the use of both, is the mixed reality when we use both. And the classic example is the Pokemon Go. In our medical practice, the augmented reality is when we use images in our robotic, laparoscopic, or percutaneous surgeries. The virtual reality is more used at this moment for training, and the mixed reality is when we use this mixed reality in our operating room, for example, in this with Patrick Pesot and I. It's common at this moment to use all this technology of the high quality technology in the planning our surgeries. For example, in the liver, we have the possibility to view the tumor and localize the tumor, the relation with the vessels, the relation with the portal vein, for example, in this case, and the segment and subsegment position of the tumor. This is a relatively common at this moment in our surgical practice. but we have the possibility to use all this technology in our clinical practice. For example, in these patients with colorectal liver mets, it's possible to view with mixed reality. With ultrasound, it's possible to view in one screen the classic ultrasound, and in another screen the augmented reality. And it's very easy to interpret the different organs, the different vessels, and the tumor. And in that case, we complete with the electromagnetic navigation system for introduce the needle in the correct place in the tumor. This is a very interesting and powerful tool for us. But it's necessary to definition of all of these new things, and really we don't have a definition. For that reason, last year we make in Strasbourg with Professor Jacques Marescot the Strasbourg International Consensus for 4 definitions: computer-assisted surgery, imaging guide surgery, hybrid operating rooms, and surgical guidance system. I talk today only for the first one. The first definition is the computer-assisted surgery, because all our practice and all the system at this moment is input, process, and output. It's our mind, our computer, all is input, process, and output. The computer-assisted surgery is not only the broad usage of information technology frameworks to enhance physician skill. It's more than this. It's create super surgeons. It's augment sense, imaging guide surgery. Cognition is more smart, in artificial intelligence, and execution, robotic, with the aim of provide more precise, the precise surgery is the key, simpler and safer procedures. Augment sense imaging guide surgery is make available more visual information layers. For example, more spectrum. The key of this is, for example, is in using in green in our surgeries. It's more resolution. For example, in this case, we make a laparoscopic ablation in the liver, and we check with the Servicio system the cells, the vessel, the vascularization, and the destroy or not with the ablation. And the transparency of the organ is fantastic during, for example, laparoscopic or robotic surgery or percutaneous. We have the possibility to view not only the organ, it's possible to view inside the organ and the tumor in the organ for localize this. Repeat, precision surgery. All the information through our eyes, 70%, but not only for our eyes, the information inside. The second thing is the augmented cognition. The augmented cognition is, for example, use the artificial intelligence, deep and machine learning in our practice. It's not my team, another team in Ircad, France, work in this laparoscopic cholecystectomy with the idea to, with artificial intelligence, to localize the several steps of the laparoscopic cholecystectomy with the idea to the machine to write the surgical reports. It's interesting, it's very interesting. The second step will be the GPS during our laparoscopic surgery. And the third step is necessarily more time for the third step, is the automation of with the robotic in our practice. And finally is augmented execution with a robotic, with laparoscopic or through a laparoscopic way to percutaneous to through endoscopic. Professor Silvana Peretta said, and I'm totally agree with her, the future of surgery will be flexible and robotic. And the future is not future in 50 years, future in less than 10 will be robotic. No, because robotic, and Armando has the man who was the most important experience in the one of the most important experience in the world, is a robotic It's not for because it's more comfortable for the surgeons or more easy to practice or the short learning course. Because the robotic has the possibility to include in the robotic more easier than laparoscopic, introduce all the GPS, the artificial intelligence, the images, the guidance system, etc. For that reason, in my opinion, in the history of surgery, in 100 years, the history of a surgery said, oh, I remember the laparoscopic. Laparoscopic was the bridge to the open to the robotic surgery. About the liver, about the percutaneous imaging guide surgery, one very interesting thing is the use of a technology in our practice. For example, the guidance system. The optical guidance system has the possibility to change the invisible to visible. It's possible to treat tumor with not possible view. And it's a totally new concept. And it has the possibility to introduce the needle in the correct place only with the help of the machines. The machines work with us. It's not only optical. Now we work more and more with electromagnetic guidance system. For example, this is one electromagnetic guidance system to use during our laparoscopic surgery in the ablation, and it's possible to view the tumor and localize and introduce the needle and check the position. It's not only the needle with the tumor and the ablation zone. It's a lot of information, and it's with very short learning curve. In one practice, and without this technology is very complicated. But the progress of this has the possibility to introduce multiple needles. This is Reto Valle experience. Professor Reto Valle works in Austria, is a very close friend of me, and is introduces several needles and destroy tumor with, for example, more than 8 centimeters. It's totally impossible 5 years ago. Now the world changes every day. It's possible the hepatic resection we replace in less than 2 or 3 years in the percutaneous procedures in more than 50% of cases. But one question is, okay, all of this is Disney, all okay, all of this is fascinating, but really, is a landmark or is only the gimmick? Well, it's one of our fellow in Strasbourg, Federico Dabrier. Federico Dabrier is a French surname, but he's an Argentinian surgeon and work at this moment, returned from Strasbourg and work in Rosario. And Federico Dabrier has, with Alex, worked together in one very interesting idea. Compare in the very simple experiment one Alsatian grapes in the box and use the expert at the beginning with the ultrasound and needle, the classic maneuver to introduce the needle in the tumor, for example, in our surgical practice. And the beginner and expert with the electromagnetic guidance system. The results of this paper, of this study, is a beginner with the technology has a better results than expert with the classic maneuver. The end of discussion is the end of discussion. The technology is not only a good thing, beautiful things, has better oncological outcome, is more precise surgery. The most important thing in this paper, because I am an expert, the expert with the technology has better result than the expert without this technology. It's not only for beginner. For that reason, today, however, surgical resection is better. I'm not sure, because at this moment, the ablation with all this technology has the same result or better than surgery, but the only difference with the surgery, the patients has out of the hospital in less than 24 hours. But it's not only incredible things. We have a problem. The problem is the is the real, our tumor, for example, is in the real world, and we work in the imaging world, and it's necessary to overlapping things and match this, and it's not easy. For that reason, we need to, because the people breathe, movement, pneumoperitoneum, surgical position, etc., change. And we have some Euclidean error. Euclidean error is the error of the top of the needle and the center of the tumor, for example, in ablation. And this is change. It's very interesting change. In the past, at this moment in Latin America in several centers, we use the hands-free ultrasound or hands-free CT for ablation. The Euclidean error, this is error of the top of the needle and the tumor, is 2 centimeters in the first position. It's too much. It's too long distance. Today, with all this navigation system, we have the possibility to reduce this 20 millimeters to 10 millimeters. It's fantastic, but it's too long too. For that reason, we work at this moment with our fellow, 2 of them from Latin America, and with Alex, and with all the surgical and engineers team. We work in some new things, is to use a surgeomic concept, and this surgeomic concept is to reduce the Euclidean error near to 0, and is more cheaper and more easy, and is not necessary to the apnea or the node movement. We have the possibility to resolution of the problem with dynamic augmented reality or with this technology. But the acceleration grow in technology. I think I have some example, but I talk a lot of time. For that reason, I prefer not talk about this in case you have time, but I only said about this. In the past, the surgeons is the center of the universe, is the sun, and the patients move around us. It's not a good thing, it's a working alone. Later, the patient was the center, and multidisciplinary team around the patient. But at this moment, change again, and we have a team of teams and work together around the patient. Not only the surgeons, the doctors, it's the technician, the nurses, the engineers, the engineers, the computer scientists, research and develop, and another actor, the artificial intelligence. And it's another person, and artificial intelligence too. For that reason, we work with the young generation in different topics, the clinical and research fellowship in Buenos Aires and in Strasbourg, the ISU Ircad course in France, and in next year in Taiwan, and I hope, Armando, in 2021 or 2022 in Latin America, Ircad, and our university master with the University of Strasbourg and the ISU Ircad and University of Strasbourg. Our master is online and on-site master. Remember, the quote from Darwin is not the stronger of the species that survives, not the most intelligent that survives, is the one of the most adaptable to change. And Carlo Pellegrini, past president of the American College of Surgeons, said it's not only appropriate for the evolution of the species, it's for our current situation. I am totally agree. Thank you very much.
Well, wonderful. Thank you very much, Mariano. Thank you very much. It's an amazing presentation, your work and everything that you achieve. But my question for you is, well, usually, how is this creative process? You are working in Buenos Aires, and then you imagine, oh, I would like to have this thing, and well, how it works for you?
Well, I work with my well, the first ideas was here in Buenos Aires with my team, and later I remember the first ideas. When I arrived to Strasbourg, I talked with Professor Jacques Marescot, and said, well, I remember the first time. Jack, I have 9 crazy ideas. And Jack said, okay, Mariano, your ideas. And the most important thing is our chairman is said, Mariano, it's a crazy idea, 50%, but you have a my totally support. And we began with this. Some ideas, when I discussed with Alex and another engineer, said it's not a good idea, really it's not, or same, it's impossible, or said it's impossible, but, and in that moment we developed this impossible but. It's fascinating. But for example, now our most important, one of the most important projects at this moment is surgeomics. It's not possible to talk because the IP protection or something, but the surgeomics was began in Buenos Aires with Juan Verde and part of our team, etc. And later, Juan Verde moved to Strasbourg, and at this moment, he worked with us in Strasbourg.
Do you believe that working in an environment with few resources stimulate your creativity to look for better solutions and cheap ones from our day-by-day work? Because I believe probably in Buenos Aires you don't have the best needle, you don't have the best X-ray equipment, and so you have to turn around to get the same results that we have in the first world country.
No,
and,
my smile is because your question is a very smart question. Yes, of course. I think the solutions in Latin America, in Argentina, but it's similar in Latin America, but in Argentina it's worse. We have terrible things. It's for the government, for the politician, for the economic reasons, etc. The rules change every day. It's terrible. It's impossible to organize something. But
we're living this now.
Yes, in one word, we change every day. When it's not possible to organize nothing, because it's not possible to organize in 2 months, we have some experience in this matter. And when we change the surgery every day, and it's necessary to say, well, the paradigm of the surgery is not true. It's necessary to change for the new one. Our mind is better than the classic mind of in the first world, because all function is all good, is perfect. For that reason, I think the Latin American people has benefits at this moment.
Okay, thank you very much. Thank you very much for your time and your presentation. It's a privilege to have you here. Luis, I don't know if you have any questions from the audience or.
I don't. My question is it's my question. Mariano.
Well, we are going to continue our presentation with Jack Liu from Taiwan. And I can speak about Jack and its project because I had the privilege to see this idea and the first prototypes and how they improve with the time. But I have a question for you. Why did you decide to work with this thing? Change the view of the surgeon from 2D to 3D. Why? What motivates you to work on that, and how you did that? Jack, it's your time.
Okay, thank you. Okay, so I share my presentation. Okay. Okay, so thank you very much. I think I really appreciate a lot that Armando and also Luis comes to my lab several times, and they saw our 2D to 3D systems. And I always ask them to test our assistant every time when he came to Ircad, Taiwan. And so, yeah, so I think that's the reason why we can make the things happen, because we have a lot of Ircad faculty and Ircad family, and they always help us, help engineer to improve the technology. So finally, we can make the things better and better. Yeah. So today I will share my story about the 2D to 3D system, what happens in Taiwan. Okay. So as I mentioned before, that why we do the research here, because we are one part of the Ircad team. At the previous talk, as Mariano just mentioned, the Ircad transfer, they did a lot of research, and they do a lot of things very advanced. So we follow the same rules, starting from Strasbourg. So we have a research team established in Taiwan, I think it's 11 years ago. And after that, I joined the team, and we work with those faculties. They come from the worldwide, and we think what we can do in Taiwan. Okay. And on the other hand, we have the other resources that in Ircad, Taiwan, it is also one part of the Shouchuan healthcare system here. And this is at hospitals healthcare system here. And it's totally around, they are around 3,600 beds. So, which means that we have a lot of stories we can learn from hospital. Yeah. So we try to learn what surgeons need, what doctors need, and how to make things better, to give doctors, surgeons, physicians better tools to make things better and better. Because I believe that when we do the medical device research, I think the final goal is to make the surgery have better quality and better outcomes. So that's why we learn from here. Okay. So if we go back to the story, okay. So as you know very much, well, that's the surgery coming, it starts from open surgery. And right now, I think half of the surgery was done by the minor invasive surgery. So laparoscope, single pore, or the nose surgery, it already happened a lot. But what will be the next? Okay, so I agree very much with Savina, also with the Mariano, is that I just quote this sentence again, Mariano. Yes, the future of surgery will be the flexible and robotics. Yeah. So let's see what happened already here. So at Strasbourg, they did a very well story. That's limber surgery. That's Marsco do the surgery at New York, and patient was at Strasbourg using connections and also the robotics, and it was happen. Okay. And also the Da Vinci was very popular right now. Almost every surgeons, every doctors knew this system. And I believe most of the surgeons like some parts of the Da Vinci's. For example, maybe they like the 3D image, maybe they like the ICG image, maybe they like the position or like the surgical tools they have been provided. So I should say this is a successful medical device stories that encourage us very much. And they also keep moving to a single pore robotic platform. Okay, but on the other hand, for the flexible, there are also a lot of things happen. For example, one thing just mentioned by Mariano is that in Strasbourg also there's a robotic flexible platform, and also in United States you can find some company or giant company, they do the research to make flexible and robotic together. Yeah, but I should use this PowerPoint here to describe. This is learned from Ircad Strasbourg. They separate the future of surgery into 3 parts. One part is the instruments. I think this is the fundamentals to operate the procedures. And the second thing is the vision. That's what surgeons look at. And it's very important because what you see is what you believe. And the third thing is the intelligence. I believe this part is happening right now. And artificial intelligence will make things change, make the doctors, make the surgeons become not work alone, but work with everyone from the global. Yeah. So, but look at this picture, we can find that if surgeons want to do a minimally invasive surgery, what is the most fundamental? they must buy an endoscope. Okay, if they don't have an endoscope, they cannot perform the minimally invasive surgery. So the endoscope system is, I should say, it is the fundamental, but it is also very important in the minimally invasive surgery, because if the endoscope is good, the system is good, then surgeons can have a better image to perform the surgery. So right now, I think if we look at this endoscope system, you can separate it into rich endoscope, for example, like laparoscopes, for example, or you can separate it into the flexible endoscope. It is quite common in the gastroscopy or colonoscopies. And also, if you want to use resolution to separate it, you can find it starting from the standard resolution. Right now, most of the system was Full HD system. And also, you knew that the 4K system already happened. And in the Medica at the show, there are also some companies show the 8K system endoscope. So the resolution will be always increasing, okay? But if you look at the dimensions, it is only 2 dimensions. Otherwise, it's 3 dimensions. I will describe this later. And also, if you look at the function, you can find that there are some near-infrared image, narrowband image, and ICG image to help surgeons look things better. So I show that, for example, the resolution. Okay, when you move from the Full HD system to a 4K systems, that which means you have 4 times resolution, 4 times pixels, but which means you can look things in more detail and make things more clear. But it is still a 2-dimensional image. Okay, and for the other things, the ICG image, it shows some points to something that image guides to help surgeons to find out some lymph nodes, for examples. But it is still in 2-dimensional image. And what surgeons performs to do the surgery is still on a 2D image, okay? So the final thing is to make things different is the 2D and 3D image. So this is a paper shows that the 3D, if you compare the 2D image with the 3D system, they shows that you can improve speed, okay? And you can show that you can have greater accuracy and better precisions. And it also shows that you can shorter the learning curve. So we believe that 3D can really help surgeons a lot, especially for the maybe for the younger surgeons when they learn the surgery, learn the minimally invasive surgery, the 3D can really help them. And on the other hand, you can imagine that in our real world, most of the humans have 2 eyes, okay? So we look at the things, look at the world, it is 3D, okay? So you can touch everything very quickly because you have a 3D dimension, okay? You know what is here, what is the related depth information. So you can imagine if you close one of your eyes, okay? And you want to touch some things, or you want to do some very fundamental, you will lose the dimensions. So you need the learning curve to make things better. Okay, so the idea is coming from here. Why we do this? Okay, you can see that in the how to make things happen. Okay, so if we want to show a surgeon 3D image, what is needed? For example, you need a 3D endoscope. For example, you need a 3D display. This is the fundamentals. Okay, so when you have the inputs and outputs, then surgeon can show the surgery on the 3D. And on the other hand, regarding the functions type, okay, we can control the 3D image in front of the screen or at the back of the screen. Or some surgeons like the more stronger 3D, or some surgeons like the weak 3D effects. So these are the functions that need to be considered when you design the system. So if we look at a 3D display, currently you can have several kinds of choice. The color glasses, polarizers, shutter glasses, or head-mount display, some things. But right now, only the polarized glasses type 3D display got the medical device certifications. Okay, and for the endoscope system, if you want to have a 3D endoscope, maybe you can choose for example, the Karl-Storz, they have a 3D endoscope, or you can choose the Olympus, they also have the 3D endoscopes. But if we look at these 3D endoscopes, they need to put two lenses here, okay? In the original 2D endoscope, there's only one lens here. But if you want to make it as a 3D endoscope, you need to put two lenses here. So when you put two lenses here, there's something happen here, okay? It will reduce some viewing angle, or you will have very limited endoscope choice, okay? And some kinds of scope, you cannot rotate it because it will make 3D difference, or you cannot do the zoom in functions by this kind of design, and you cannot adjust the 3D effects. So there's a lot of things can be improved in this area, okay? But we always think that 3D is very important for surgeons, but how to make this 3D better and better? So after we talk to a lot of surgeons here in the Ircad, and they give us suggestions. Why not you just convert the 2D image into a 3D? Then every operation room will have the 3D during the surgery. Okay, so we try to understand how the 2D endoscope work, and we make a system here. It is a very complex calculation system to transfer 2D image into a 3D. So we calculate the related depth information for X pixel, and then we render the left image and right image, and then we can show the 3D correspondingly, and you can use your current 2D system. So based on these designs, there's a very important thing is that we can fit any kind of endoscope, no matter which kind of size, which kind of angle, and you can keep all your 2D functions, and then you can adjust your 3D effects. So here we show that we have 5-level design. If you are a 3D fan, you can choose the level 5, the strongest one. But if you are first-time users, you can choose maybe the level 1 or level 2. So, and also it depends on the specialties. So, which means that we can control the 3D by surgeon. You can choose the most comfortable one for you to use. So based on this kind of designs, we can transfer every kind of 2D endoscope into 3D at all of these specialties, from general surgery, gynecology, some things, and also the gastroscopies. But what will make 3D better? So we try to combine several things. So we try to combine 3D and ICG image. As I mentioned before, ICG is sometimes important to surgeons, but it is still on 2D. But if you're using our system, we can convert the 2D ICG image into 3D too. And also, that's very important, is also mentioned by Armando at Stages. You can also convert any kind of 2D flexible endoscope into 3D. And we also performed the trial in Ircad, Taiwan, and we proved that there are a lot of things can be done here. After that, we also consult the surgeons at Japan, and they're using our system to perform the ERCP surgery. There's no one performed this before because there is no 3D flexible endoscope. But when they're using our system, they found that several advantages happens. Easy to get a sense at the flexible surgery, easy to find out the relation, information, and enable sensitivity identifications. It really helps doctors and physicians a lot. And also for the diagnosis, you can find that some doctors, physicians will using the narrowband image. But if you have our 3D system to enhance it, it will make the structure more clear and clear. Okay, so it will help the surgeons to do the diagnosis to increase the early diagnosis. Here, I will also share a video that I recorded.
In Ircad, France, it was very interesting because we test that for laparoscopic surgery and also for flexible endoscopy. We use more than 66 medical practitioners, some experts, intermediate, and some very novice. And the results were really spectacular because for each task given to the medical doctor, always there was a superiority with the 2D, 3D system. And something very interesting also was no side effect, no fatigue of the eyes, no headache, no nausea, and for all the operation that he has to perform, it was easier and faster with the 2D, 3D system. And that's the reason we are going to publish in a very high-level journal, because statistically it was really a big success. So why today a 2D, 3D system is very important for gastroenterology and flexible endoscopy? Why? Because today we have more and more complex procedure in endoluminal surgery. You remember at the beginning it was only polypectomy, and that is easy to perform. But today we have mucosectomy, we have ESD, and that is more complex to perform. And in this case, when we have the 3D image, it's absolutely easier to perform the procedure.
Scope, as you can see here, me, Silvana, and you asked me yesterday how I feel about the 3D. Wow, this is just perfect. The depthness sense that I have here, and I can touch everything here. I've never feel that before in 2D. So imagine that for any therapeutics on the whole field of endoscopy, that's going to be a major advance. Maybe the guys on diagnosis don't feel that, but for therapeutic, for endoscopic surgery, that will be, to me, what I'm seeing here is a major advance, and I want to have one right now in my endoscopic suite. So what I have.
Yeah, so I think I will use this the last two presentations. So when we make the prototype here, and we use the animal labs to test it, and we set up the factory to manufacture it. And we passed all the certifications in Taiwan, in Europe, and also in Japan, in Australia. And we found out our partners global. But I think the most important is that we have our Ircad partners, and all of this will support us a lot to make things move forward. So finally, it's quite interesting that as the same as the Mariano, we quote the same sentence. Yeah, it's coming from Darwin's. Yeah, because why we quote this, because we think from 2D to 3D is some kinds of the evolutions. Okay, so you need to make things change. You need to change from 2D to 3D so you can do things better and better. So our next version's product is called Darwin. Yeah, so it will come soon, and the function will be happen here is for the 3D, 4K, and ICG together. Yeah, so thank you very much.
Thank you very much, Jack. It's a very nice presentation. So I appreciate your time and the view. It's a very clear how motivate you to get there. I believe one important thing that maybe is the basis of everything is that when we be in contact with Ircad, the France and Jacques Maresco, Alexandre and Bernard, the team, Silvana, the team over there, and the majority of people that work over there, they touch us, they touch our mind to try to develop something and create something from zero. And the resources that you have in Taiwan with a medical device company and the basis to create that. And I know this is your personal work, this you show the use of 2D, 3D, most for dedicated to minimally invasive surgery, but I know that you developed this for microscope, neurosurgery, and any several kinds and different kinds of specialties. And I had the privilege to have one with us here to play with, and it's really great. We touched something that were developed from zero, coming from this ideas and Ircad Center, and this it's just a wonderful job. I have to congratulate you and your team how to explain this thing. But which new projects are you working now? Which kind of thing are you trying to develop? I saw this 4K 2D 3D. It should be a huge work, huh? But do you have any other things that you want to develop for surgery in your mind?
Yes, I think that's the other product we'll show to you. I think before the end of this year's. Actually, there are two products. One is related to artificial intelligence systems in the surgery. So we design, and the other platforms, it is called a Endoscope System. And it can do the 4K 3D real-time calculations, processings, and calculate the related informations. And we try to show some useful informations during the surgery. This is one of things. And we also design the navigation system. Yeah, but it's more for the brain surgery. Yeah. Okay. So they will be the other products. Yeah. But I think it's always good to talk to all of you, especially talk to Armandos. Yeah. You really support us a lot. Yeah. Every time you came to Taiwan, I always ask you to see my prototype. Yeah. Yeah. But your contribution is very good. Very useful. Yeah. Yeah.
Oh, that is great. So thank you very much to be with us today and showing your experience and this opportunity. But well, we have a new challenge now. It's not ready yet, Ircad Africa, but we have some people that are start to work over there even before the building is ready, and I really want to know how it is to create a IT team that focus on surgery and healthcare in the middle of Africa. So David, if you could share with us some ideas related to that. I know that you have a strong support from France, but how do you think about that? How it works for you?
Well, first of all, really thank you. I'm very honored to be here, and for some of you, it's the first time that we meet. And as you said, we are the newcomers in the family. I'm the little brother here, and yeah, very honored to be with you. Before I show my presentation, I'm just going to talk about a little bit of answer to your question. So, as you said, we started really before even having like a building, and today it is under construction. But the way we work today is really closely to Ircad France and AHU. So today we are an extended team. We are a joint team, and actually we don't even separate ourselves. It's the same team we called the Surgical Data Science team, where we collaborate on different projects. Research, development, everything is really in common, and yeah, we're trying to really work together on everything. Today, as you said, it's a really small team. We are 6 engineers here in the R&D team here, and as I said, we work with in France. There are 20 to 30 engineers. And yeah, like it's a really great adventure up to now. Collaborating on some projects, learning from their experience, because they've been there. As I said, they are the big brothers, and we learn a lot from them. And we have very talented engineers here in Rwanda, in Africa, and yeah, we get together and work together. So today in my presentation, I was just going to show you an example of a project we worked together. And yeah, really emphasis on that collaboration. Even though collaboration is not the word, it's a really same team. So it's the same team. And
well, how do you get this job? How do you apply for that? How it is for you to create this team in Africa? You are the leader of this team. So how it is for you to know to imagine to work with French center and to get into the healthcare? Do you this was your focus before, and when you finish your graduation or your university, what was your focus? Probably was on that. So
oh well, in this case, it's funny. I've actually studied in France.
Oh, okay.
Yeah, I studied in Toulouse. I studied in Toulouse after my master's degree. Came back in Rwanda. I studied computer vision and robotics. So when I came to Rwanda, I was just hearing rumors that a big project is coming here in Rwanda, and it's going to focus on surgery, image-guided surgery. And I can't lie to you, I was really excited because this is a really big thing here. There's no other thing like this here in Africa, basically. And I was lucky enough to go and assist to a presentation of Professor Jack Marasco. And yeah, he mentioned some topics that I've studied and that I wasn't really thinking to find easily here in Africa. And it was really exciting to work on such advanced technology, and plus in the medical field, which is a noble field to work into. When we were younger, we all wanted to be doctors, to save lives, etc. I didn't do the doctor part, but today I can apply my knowledge into the medical field and yeah, work with surgeons and learn from them as well, because we sometimes we work on, I mean, not sometimes, all the times, we work with medical images, and first we don't really know what's going on, and we have to learn what's going on and all the medical information, and yeah, we might end up knowing in the medical topics. I remember Luc Soler at that time was the director of the R&D team, and we asked him how does he, if he's just a computer science, if he just has a computer science background, how come he knows that much about surgery? And he was telling us how it's just talking with surgeons, exchanging with them, and work on those different projects. You get to know how it works, and yeah, you learn the language, lexic of surgery. So yeah, that's my experience here. And I know today I'm representing my other colleagues, and that's something we had in common. The project itself, we've seen the presentation of advanced technology used in medical field, and we were really, really, really impressed and wanted to be part of this big family. And yeah, here we are today, 6 engineers. We have a PhD student, he's from Cameroon. And yeah, it's a great adventure. I'm really excited to be part of this. Yeah.
Well, I don't know if it's a coincidence, but I was in Rwanda with Jackman. He presents for a group of
Exactly.
engineers. Maybe you were in the
I
middle of
was
this.
there.
I
I was
remember
there.
it was almost 50 people. The room was crowded. I was really surprised.
Exactly.
So,
Yeah.
Dave, please continue your presentation. Don't want to stop you anymore. It's a
No
privilege to
problem.
have you here.
Thank you. I'm really honored as well to be with you guys. For my presentation, it has a lot of things in common with Dr. Mariano Jimenez, and that's also an illustration of how it is a family, since we have the same base on what we were working. Going to share my screen. Can you see my screen?
Yes, we can.
The presentation itself, or you're seeing the?
No. It's you're the presenter mode.
Oh, well, I have to switch that. Sorry. Up. Okay, there you go. All right.
Yes.
Okay, so as I was saying, we are really a same team, Ircad France and the
I can see you beside a very important names, huh?
Only
Toby, Flavian, and Jack. Wow.
Exactly. So as I said, we are the same team, and those names are my boss and those with who I work on a daily basis. Sorry. So you know them. I don't think I need to to present them. So the way we work here is really an exchange. Daily, we have a system of chat where we exchange. We always have video conferences daily with mainly with Flavien, with Toby, where we get that sense of having a same team. So this is not really new for you guys. What we do here in the R&D is the same as Jack Liu presented. We divide our research in 3 parts: the augmented surgical vision, where the idea is to augment the vision of the surgeons by adding more information on what he sees. The augmented surgical decision, of course, the artificial intelligence, being able to automatically detect structures, to track anything automatically, structures, basically really funded on artificial intelligence. And the augmented surgical gesture, which is where we go towards the robotic. So today, just for the topic we're having today, just going to present one specific project that goes into the augmented surgical vision. I'm going to go a little bit in details on this one. So augmented surgical vision, as I said earlier, improving the vision of the surgeon, bringing to him more information, making his work easier. So here, for that purpose, we're going to work with augmented reality, where it works by having first a 3D image. Just to give an example, we're going to take a CT scan of a patient before his surgery and be able to segment a region of interest. And how it works, we're going to fuse these 2 images, bringing more information on what the surgeon sees. So here, basically, it's making it transparent. We can see below the structure that we had on the right earlier. And we see vessels, etc. That's it's really a great thing because we get to see the patient being transparent and see below. So always in this field of augmented reality, we have to deal with what we call registration, where we have this model, with this 3D model that we have to superimpose on the real object. As you can see here in this example, on the right corner, bottom right corner, it's a kind of mouse where it is tracked with a sensor in an electromagnetic field, and we just have to find here manually the position and actually get to position it in the right position. So this is the rigid registration. There's a little small challenge that we face when we get an image of a patient, let's say a week before, he's in a specific position, and then the day of the operation, he is in a different position. So rigid registration here wouldn't work. So we get what we call non-rigid registration, where it's the 3D image is going to be softly going to get the exact new position of the patient. And to this one, we get another challenge because the patient breathes. So if he breathes, of course, the organ's going to move. And our registration doesn't work anymore. So the goal here is to be able to simulate the movement of the breathing motion. That today is it's a topic of research that is going on in Ircad, France, especially, where they're going to use RGBD cameras, the D standing for depth, which going to project structured lines on the structured light, sorry, on the patient, and get to know the motion, and later on with algorithms we can simulate that. As another example, Dr. Mariano showed this one. We are able to segment the gloves and not have the image projected on the glove, which wouldn't be really nice. And here we are able to just segment the gloves and really have this vision of actually kind of touching the organs. So the kind of medical application we have are multiple: radiotherapy, percutaneous surgery, gynecology, and navigation. And today I chose to talk about the percutaneous surgery, which is a project that Dr. Mariano knows really well, because he worked on it basically, and he showed us some images earlier. The percutaneous surgery here, the goal of this project here called ARES, which stands for Augmented Reality for Echo-Guided Surgery. In this case, we're going to talk about thermoablation of hepatic tumors. The idea here is to locate where the tumor is, and with an ultrasound, for example, an ultrasound probe, and insert a needle directly to the tumor, change the temperature at the tip of the needle, and destroy the tumor. So this practice really works for small tumors up to 3 centimeters, and when we have larger ones, we can use multiple needles. So that's one of the projects that's been going on in Ircad France, and we participated as well here in Ircad Africa. The objective here, overcoming the guidance limitations, because as Dr. Mariano again said, being able to follow a needle in ultrasound images is really hard, and you can imagine me as an engineer, not a doctor. When I saw how they used to do before that, I was really impressed. I was like, how is that possible to find where you're going? But of course, you are experts and you know that. And so this project really made sense to me because it helps visualizing the needle and the ultrasound plan in a 3D environment using virtual reality and augmented reality. And yeah, of course, compensating artifacts and the poor image quality, and have all those information in one place. How did it work? The hardware we use here is here on the left, top left, we have an electromagnetic field generator. And on the right, that's a transabdominal probe where we're going to put an electromagnetic sensor. And this is going to help us know the position of the probe in the electromagnetic world. The same way, we want to know where the needle is, and we can put a sensor on it, or use this needle here on the right has a sensor incorporated inside, which makes it more easier. So the idea is to be able to see the plane of the ultrasound and the representation of the needle. And on top of that, we're going to add the trajectory of the needle, where is the target, and the distance that is needed that is remaining to get directly to the target. Here's an example that shows a bit better how it looks like. So I like to remind people that on the top right, the ultrasound image is what surgeons use only to guide themselves. And you can imagine how it requires a lot of experience to be able to go to do that task precisely. So here we're going to add on the left virtual environment with probe and the plan of the ultrasound, matching exactly the position of the probe. And we are able to show the needle where it is, the distance here in purple to the target. It can be a tumor. I mean, it is a tumor. Not it can be. It is a tumor. The position, the remaining distance to it, and we have here a kind of target to simulate if you are aiming correctly the tumor. So I have a video here showing how it is used. So the lady here is using a gelatin box with inside some chickpeas, I think, or berries, and by guiding herself on the application, she can see exactly where she's aiming. And the good thing here, you can see it on the right, is we're able to also simulate the view on top of the needle. It's like having a camera on the tip of the needle and making it easy to go directly to the target with less error. Yeah, that's another view, a zoom on the screen she had earlier. So yeah, you have those dash points showing you how you are aiming and the distance, etc. So we are also able to have to create an augmented reality of that view by showing like the red dots here will be the chickpeas to simulate organs here. In this case, you see we have the exact position of the probe, the needle, and we can see aim to the region of interest. And yeah, as I was saying earlier, this is what we use for validation. It is just a bag with gelatin, and we put inside some chickpeas representing a structure in the body, and we can use that. Here's a video, another video that show Dr. Mariano using this technology. And as you can see, we have the segmented 3D projected on the patient, and we see exactly where the probe is and the plan of the ultrasound, making it really easier for surgeons to know where they are and to insert the needle. So in this example, I'm talking about the transabdominal probe, but the same thing has been done for a laparoscopic probe. In this video here, we've added a sensor on top of it. It is also possible to maybe have it inside the probe. On this thing, the challenge here is going to be, we cannot, in this video, we cannot use this inside the patient because, I mean, first of all, it's big and I don't think it's regulatory. So we worked on another paper here, another research we've done, and that's mainly where Ircad Africa worked on, is to use a marker, optical marker, which is just a paper we're going to put around the probe. And the idea here, using those patterns around the probe, is to know, to compute the position of the probe and be able later on to add the plan of the ultrasound. So it works correctly here. That's what we've shown to the Scientific Council last year. And yeah, as you can see, we can see the finger in the ultrasound probe. And yeah, this is an ongoing one, and we've shown that it is possible to do that. So this is the kind of things we are able to do, and the kind of project we work together with Ircad France and ASU. And we have many projects going on like that. And to do that, to be able to tackle all those topics, of course, we need a really large spectrum of fields where we're going to work all of us together. Deep learning, of course, for the augmented surgical decision, the computer vision. For example, the mechanical engine here, where it's about simulating the movement, the breathing, as I said, the deformation of some organs. We have some framework here. It's called SITE, which makes easy the creation of application for navigation purposes. And yeah, web development. So it's a really large. It requires a lot of fields to work here, and yeah, we're really excited to work on this. And yeah, this is a picture of us when we went to in Strasbourg. We were just three. At that time, we were just three engineers. I'm just here. I don't know if you recognize me. And yeah, it was. We went to visit Strasbourg to meet the team and exchange with them, making the relationship easier. Because when we're just talking online and you don't really know the person, it's a bit hard. And here we met them, and we do that all the time. Whenever we have new engineers, they have the possibility to go in Strasbourg to work for like 1 month within the team in France, making them know our engineers and our engineers to know them as well, creating a really nice relationship with the team. So yeah, that's the end of our presentation. We have a lot of things going on. Many projects we're working on together, and to answer, I guess, one question that can come up is the project to work with surgeons here in Ircad Africa, in Africa, and yeah, create the same relationship we have in France. With the surgeons, with hospitals, with our engineers, and have a really flowing relationship and communication.
Thank you, David. Thank you very much for your presentation. I want to ask you exactly a question. One thing is, I understand that you work as an extended program with France, but do you have a feel to go to to the field in your country and go inside of the hostels and see the ward and see how they work and look and the way that they work nowadays, if you can help them to do something. Do you have this kind of experience? Did you went to some hospitals to see how they do the things? And as you told before, so I cannot imagine how they do things like this. So
Yeah.
which is your feeling regarding to this in Rwanda?
So here in Rwanda, we've been in contact with surgeons, of course. Some of the co-directors that are going to assist the courses when Ircad actually starts giving courses, and we've exchanged a lot on the equipment they have, the practices they do. That's something we've done. I've done with of course, under the direction of Alexandre, where we are today creating that relationship. So we meet surgeons very often where we exchange. Of course, we show them what Ircad is able to do, and we ask them about what the equipment they have, what are the practices they do. For example, in this case, about this presentation, as I've done, how much, let's say, percutaneous surgery they do. Is this something that will be really interested for them? And I haven't gone yet in a hospital, but that's something I'm working on with one of the surgeons here, who promised me to invite me in one of his surgery to see the equipment they have, what they do, how everything is over there, so that we can work on specific projects for them to, for something we can develop here for the surgeon in Africa, in Rwanda specifically.
Yes, because in between the two different words and resources, and I see this here in Brazil. So we have public hospitals, have place where equipment from the view of laparoscope is the standard one. Sometimes it's before HD, and so it means that we have a huge gap in between the last resources and technology and the average of the hospitals in Latin America. I can speak about it, and I'm really curious because if I am an engineer working in a place like that, I believe it's very nice and fancy to develop the tip of the sword, the last frontiers, but in the middle. How can I help my surgeons locally with maybe simple solutions or improve what they are doing with antique technology? And I believe this is a challenge, and I really believe that Mariano feel that in the day by day. When he is in Strasbourg is one thing. When he's back to Argentina, beside the Dicing Foundation is a nice place, but sometimes we go in the countryside. We try to demonstrate our technique in small places, and we don't find the same technological resources. So, it's an open question. What guys do you think about that?
I'm going to start here. You're really right. This is a question. This is a feeling we've had in the team, actually. For example, I've done some presentation where I kind of showed what's more in Ircad France. And the surgeons here are really amazed by what's possible. But there's always this question where we're like, okay, that's really amazing, but we don't have that here. So how are you going to help us? And that's the really core question we want to solve here in Ircad Africa, where we want to offer a solution that is really, how can I say it?
Local made.
Yeah, local made and adapted. Adapted to the region. And of course, if it's adapted to this region and it doesn't, we can use it abroad as well. Like it doesn't mean it's going to work only in Africa. It's something that can be used in Latin America and also Europe, Asia, everywhere. So yeah, that's we're focusing on some technology that are of course cheaper. Let's say the ultrasound technology. It's mainly it's used a lot here. So the project, I guess, we're going to work on that, for example, and yeah, offer something that is adequate here, and so that our surgeons, we can present something our surgeons would like and they can use on the daily basis.
Armando, David, I think, of course, it's important, the technology, and it's important, the money, of course. But however, the most important thing is the ideas and the human resources. And it's very common in our countries, in my country, but I think it's the same in Latin America. I said, no, it's not possible. This is not for my place. It's no, because it's easier. It's the easier answer. But I think it said, no. Of course, not all new is good for new, but it's necessary to incorporate some very interesting and not very expensive things in our clinical practice. For that reason, I think we need, not as possible, Armando, our generation, but the young people and the young surgeons said, and the young engineers, etc., in our country said, open mind has possibilities, dream a new surgery, and later we have the possibility to work here in Latin America. For example, in Ircad, Brazil is a fantastic place to work, and in Strasbourg, in Taiwan or Africa, etc. And this is the second step. The first step is open mind, said it's possible, I have a dream. I think it's necessary. It's necessary. When the first idea is not possible, stop. What is your opinion, Armando? Because you are a leader, a real leader. What is your opinion?
Well, I believe that we try to modify our environment. We try to improve education. We try to improve some ideas and develop new technologies. And as you did, we have to partner abroad to develop our crazy ideas, and sometimes it works, and it's very nice to be part of a huge project. The non-disclosure agreement does not allow me to speak about the programs, but it's very nice to put your mind in some project where you want to see the final thing that is going to help a lot of surgeons, and you think more about your reality, your environment. And I believe this is the beauty. And I am very happy because you and Jack finished the presentation with amazing phrase that is maybe you have to adapt. You have to adapt. And when you are in France or US, you work with in some ways, but when you are back in South America, and I believe for Africa and several places in Asia is the same, is a totally different reality. And so you have to adapt and try to do your best. And sometimes this is the point where human resources has to overcome the technology difficulties. And but we want exactly the opposite. We want to have the average surgeon or human being performing as a huge expert, improving safety, as you are doing with your research, Mariano. And I congratulate you for that, because when you try to improve something to bring safety, accuracy from something that is like ablation, the minimize the error. This is fantastic. This is fantastic.
I think that's one important part for we have to explain about the new generation. They have to see the future. They have to see how to reach the possibilities. A lot of the people from the new generation, they believe that they want money now, and they need the results now, and not so much. So many people try to, after the first, I can say the first fall, they can stand up again and try again. So they need to realize, they figure out the possibilities for the future, and this is the possibility. And so, okay, they prefer to buy the new device, the new ready device, much more than develop, because in Latin America, and I think that's, I don't know, but the same like Africa, the government is not, they don't push a lot these possibilities, and we have to put everybody together, the government and the new ideas, and we have to believe that this is possible. And I think that in some people, some countries or some continents like Asia, they have so many support from government or some companies to push their ideas, and this is the problem here also. And I think that we have to, the people that, the students, they're not only doctors, the people that believe in healthcare system, in new possibilities, they have to believe in new ideas and push their ideas to improve there. So this is the problem that you have to show for the people, because we try to do new device, and the first idea that we have, the people said they are crazy, but we are not crazy. We are trying to construct, to build new possibilities, to give for the people new possibilities to treat our disease. And it's not only their disease, it's our disease also. So we have to think about this, and to give these new possibilities for all the new generation, how to improve. And and here you have very nice people, and people with good ideas. We see Armando, we see Mariano. They gave for us all the possibilities. Professor Marisco gave for us all the new possibilities to improve. And you see Jack, you see David also. So we are trying to put all the ideas together. And if you got this, we have new and good results. This is the possibility that you have to show for the new generation. Alone we are nothing. Together, nobody can catch us.
Jack, I have a question for you. So we were speaking about development, and sometimes we commit a mistake and we have to return back. How many times it happens in the project 2D, 3D? Do you know how many that you start and said, I'm going this way? No, it's wrong. So I have to return back. And can you explain for us the process by itself?
Yeah, actually, this is a very good example, because first, I believe in the beginning, when we get the idea to convert 2D to 3D, then there's a lot of latency, I think. Yeah. And surgeons say, they gave us the comments that the image is beautiful, but you need to improve speed. So we try, and finally, I think there are 3 or 4 times, I think 3 or 4 years, I should say years. Yeah. So every time, for example, every time you came every year, so we need to modify again every year. Yeah. So finally, but I think it's a very good circle, because because we are from Ircad, and Ircad, it is good to have this kind of platform. So for example, in Ircad Taiwan, we not only share the resource to us, we also share the resource to our local company. Mm-hmm. There's Dr. Wen, the director of Ircad Taiwan. He has a dream is to make the Ircad Taiwan also with the Ircad family is a accelerator and incubation platform for all of the people who wants to make things to change their local surgery, local things. So we share our resource, not only from Ircad Taiwan, but also from hospital. We encourage engineer or the startup company to show their idea to the doctor surgeon here. And we welcome them to do the animal lab in Ircad Taiwan. And we also help them to do the clinical trial in our hospital. And we also show them the roadmap, how to convert from prototype to products. And we share information from them, how to do to pass the regulation, how to design the factory, something like that. And finally, we also can help them to promote the product together through the Ircad, because we can show their products to all the people, friends come to Ircad Taiwan. Yeah, so I believe this the Ircad family is very important. And since you are from the Mariano from Strasbourg, you from Brazil, and David from Africa, and all of these centers, I believe we can work together, and then we can share different companies' idea. And then, for example, a company come from Taiwan, and they can share idea to you in Brazil, and can share to Mariano in Strasbourg. And also we can accept to get an idea from your side, so we can make things become global. Yeah.
Thank you very much. Mariano, by the way, where are you now? In France or in Argentina?
In Argentina, in the middle of strong quarantine for the COVID-19.
Yeah, yes. as we in Brazil.
Oh, so. Yes. I have several things in Strasbourg, because now Strasbourg work 100%, but is the airport in Argentina are totally closed at this moment. But well, it's our world. It's our world. Yeah, Armando, about the Jack said I think I totally agree. It's very interesting, because 10 years ago, the most important thing is about the new device or something is a great idea. But later, 5 years ago, it's important not only the idea, the great idea, is the possibility to do the great idea, but build some device. But we have some device. But now, this is not important. It's important, a great idea, and one device, and with the possibility to very quickly FDA and CE mark approval. Every time is more complicated. For that reason, is the great idea is, of course, is the first step, but it's not the final step. And for that reason, it's necessary to work together. In Strasbourg, we have a very interesting thing, and David worked with us, and is fantastic. We work all time with the engineers, bioengineers, and computer assistants, and the surgeons, endoscopists, all time work together in the operating room, in the research platform, and in the bar, in the cafeteria too. And it's fantastic, because I said, I have Alex, I have some idea. I said, no, Mariano, but I think it's better. It's create a new things. It's fantastic. It's fantastic. It's very, very excited.
Well, you touched something that is important, and maybe you have to add for this group in the next time a lawyer, because how to get the CA approval or FDA approval is a very complicated process.
Oh,
so it's I believe that you finish your idea, you get the product, and you are happy, but it's not the end. So you have to get something more. Dave, do you want to speak something?
Just to add on what you guys said. For example, here in our region, and it's probably the same over there. I know there is not much of research being done, and I think Ircad being here is a really great opportunity. Because obviously innovation comes from research, and as we were saying, if we just buy something already done and we don't spend time to actually create adapted solution for our need, I mean it's a lost cause, I'd say. Okay, maybe it's exaggerated, but what I mean is really we have to raise awareness about research and let the young people know that it's possible to actually, I don't know, do PhDs and focus on one topic and innovate and create something that is going to be used for generation and generation, and yeah, not be scared of research, but also administratively, I think research is kind of seen like something that consumes money. Let's talk about money. We invest, we put money in research, a lot of money, and it takes time to actually see a result. And that's maybe, I'm not sure, but that's maybe something that makes people afraid of such a field. And I think if they understand it and take time to invest in new technology, in resources, we have so many young, really bright people here, and we can create amazing stuff. And the money will come after when we develop the solution and innovations. Yeah.
Well, you touched something that's very important. We don't speak about money, but without money you can do anything. But I appreciate your time. Yeah, everything that you share with us in this first session about innovative surgery, because the next session is going to be with France, and Alexandre is going to speak with us, and I hope Jack also. And they are going to speak about the model, how to get the money, and which kind of development they have, how to build a team for research, and how to be successful in research, because Ircad is doing that in the last 26, 27 years. So can you imagine Jack Marisco in 2001 performing a surgery in New York in a patient located in Strasbourg? Wow, it's crazy for that time. And this is based on research and basing a lot of, to put a lot of people together to get the money, to to motivate people, to convince people, to give you the opportunity for that. And Jack convinced France Telecom for helping them to do that. One cable, special cable from New York to Strasbourg to perform this procedure. Imagine the amount of money that it cost. And so it really is really amazing. And the next webinar, we are gonna have that, because I would say that France is the Olimpo, so it is the high end. So of course you have Ircad is motivate all of these things, and so we are going to have a session totally dedicated for them in the next time. I hope you all enjoy. But I appreciate too much your time and sharing with us, because, well, we have to dream. We are in South America, we are in Africa. Jack is a little different position, because Taiwan is an amazing place. How they fight COVID, only 6 deaths and 120 cases, and how they overcome that. We have a lot to learn. We have a lot of learn from them. So it's very important to have this family getting together, putting the ideas and sharing. This is the amazing world that we want to live. Thank you very much, Luis.
So now we have almost 2 hours talking. It was amazing to put everybody together. I think that's this pandemic brought for us new possibilities to put together everybody. I know that's not the best part, where we would like to have together everybody to discuss, to drink something, very nice wine, very nice whiskey together. But in 2 hours, we have more than 200 people watching us. Just some results, some numbers in our last live. After the live, we have more than 4,000 people watching us. So it's important that this live will be recording and will be available in the Ircad Latin America and Africa, and Ircad Taiwan to watching after. And some people now it's watching us, Professor Wayne, some people from Argentina, also Mariano Palermo, Gustavo Marcucci, some people from Peru, Bihospi, Cherokee, some people from Mexico, Adriana Liceaga, here with us. From Brazil, some people from some company, from Medtronic. We have Clodoaldo and André Grativol with us. Some people from Brazil, Renato, Alessandro Zagai, and Bia. They are always they are alumni from BEST, the last BEST course here in Barretos. Gerardo from Peru also, and here from Brazil, Professor Ciongoli and Ramon. So it's amazing that the people are connected with us. So this is the idea. At the beginning, I thought that this is the philosophy of Ircad family, to put everybody together. It's nice, but not the best way to put together with the live. But I think that for the next time, we can have together, and soon, everybody. So for me and for the Ircad team here, it's a pleasure to have here. Nothing this would be possible without all the teams together. The Ircad Barretos, Ircad Rio, Ircad France, Ircad Taiwan, and Ircad Africa. So this is the idea. All the team, the AV team together to do this transmission. The live transmission is not easy, but we can do. And we do more time. I hope that the next time with more people, more people, and someday everybody together in a very nice course that will be do all the Ircads together. So for me, it's a pleasure. Thank you guys for your time, for your opportunity to share your knowledge with us. This is my message, and thank you a lot.
Thank you.
Well, thank you so much for inviting us. It's a great pleasure.
Thank you, really, thank you. Thank you for Luis and Antonio for this great idea. Thank you.
Thank you for the invitation. Welcome to Taiwan to drink beer, to drink together. Yeah.
Welcome to Rwanda as well.
And guys,
I hope soon.
I will go out to the bar.
no, and
Brazil,
guys,
we can offer caipirinha. Taiwan, we have a very good whiskey. I'm not going to marketing it, but Argentina, wow, good wines, and France, a lot of good things. Africa, wow, I have an amazing experience over there.
Yeah.
Armando, and guys, just one regard that nothing. We have important here the people that translate, the team that translates for Portuguese, and it was amazing. They are always amazing, and I hope that for the next one we have translation for Spanish. And I made this a challenge. Livia, he is here with us, so we believe that for the next time we translate to Spanish also, and so Spanish, Portuguese, we can change, and this is now our next challenge for the next live. So they are supporting us also this time. So this is it's important to say.
Well, talking about human resources and gratitude, Livia and your team, thank you very much to supporting us for free. Thank you. Guys, I see you next time. It was a pleasure. Thank you very much. We just starting in the morning here in South America. We are going to work, and it is done. Thank you very much. Thank you.
Thank you very much.
Okay.
Bye-bye.
Thank you, guys.
Thank you.
Bye-bye.
Bye. Thank you,
Bye.
Antonio. Thank you, Luis.